Alright, today we're taking a look at adding and subtracting rational expressions. It has some similarities to multiplying and dividing in the sense that we have to factor everything completely first. So that's the first step to doing these. After that, we're going to figure out the max number of times the factors occur in each denominator. And then finally, we'll write the LCD and multiply each term by the necessary factors so that they all match. I know that doesn't make any sense right now, and it kind of doesn't sound like anything to you, but let's dive right in and take a look. Before we start this, though, let's look at this example. What if we had 1/2 and then we subtracted off 1/3? Well, back in 5th grade, we learned that we have to first make a common denominator in order to do this. So to make a common denominator between 2 and 3, we said, well, 6 is the smallest number that goes into both of those. So then we would multiply this by 3 over 3, and we'd multiply this by 2 over 2. That would give us 3 over 6 minus 2 over 6. Now that the denominators were the same, now we could do this problem. We can combine the top, so it's 3 minus 2 over 6, into just one fraction, which would give us 1/6. All right? This idea is what we're going to use and then apply it to questions where there's variables involved in them. So let's take a look at this first example. We have 15 over 2x minus 16 over 3x. The first thing we always look for is, can anything factor? In this case, we just have a 2x and a 3x. Nothing can factor there. 15, not pulling anything out of there. 16, also not pulling anything out of there. So we're just going to keep it just as it is. After that, we go to building the least common denominator. In this case, we look at all the factors. Factors are split up by multiplication signs, so 2 is a factor, x is a factor, 3 is a factor, and this other x is a factor. We look at the max number of times 2 shows up in a denominator. In this specific instance, we just have 1, 2. So we would put that 1, 2 right down here. After that, we'd go to the x. The x, the maximum number of times that this x shows up in a singular fraction is once. So we would say 2 multiplied by x. All right. Even though there's a second x here, it only shows up just one time in that denominator. So we only need 1x in our least common denominator. And then lastly, we haven't taken a look at 3 yet, so we look at 3. There's only 1 3, so we're going to multiply this by 3. So in the end, our least common denominator is 2 times x times 3, which gives us 6x. All right. For the most part, we're just going to leave it as 2 times x times 3. And then at the end, we might change it to 6x. But you'll understand why, for the most part in these questions, we'll want to keep it as just each factor multiplied together. So after we have the least common denominator, we then need to go to looking at the fraction. We need to say, what's missing from this denominator that my least common denominator has? In this case, there's a 2 and an x. We also have a 3 in here, so we need to put a 3 in the bottom. So we're going to multiply by 3 in the bottom. In order to do that, we also need to multiply by 3 in the top, so that way we're only multiplying by 1. On the other side, we need to multiply by 2 in the bottom, because 2 is what's missing, and so we also need to multiply by 2 in the top. We come down here, and that gives us 45 would be 15 times 3, divided by 2 times x times 3. That's one way you could write the denominator. You could write the denominator as 6x, or you're going to see in the future that the denominators get kind of big, so to save some time, I might just write that our denominator is the least common denominator. On the other side, we're subtracting off 16 times 2, which gives us 32 over 2 times x times 3. And now we can combine this. So 45 minus 32 gives us 13. And then now I'm going to put it as 6x. The reason I put it as 6x at this step is because I'm trying to see, does 13 cancel with 6? In this case, it does not. So our final answer is 13 divided by 6x. One thing we're going to talk about here, though, is that there are restrictions to what we're allowed to plug in for x. So I like to say, or what we need to say, is that x cannot be 0 in this case. The reason x can't be 0 is because if there was a 0 right here, we would be dividing by 0, and we can't have that. All right, so we're also going to start putting in these restrictions into our final solutions. All right, taking a look at number 2. Again, number 2 is one where we can't factor, but so then we just dive straight into the least common denominator. So we look at each factor. We have 5 and a squared. We also have 3 and a. In this case, the maximum number of times 5 shows up in a denominator is 1, so we put 1, 5 there. The maximum number of times an a shows up in a denominator is 2. This squared tells us that there's 2 a's there, so we put an a squared in our least common denominator. And then the maximum number of times a 3 shows up is 1, so we also put a 3 in there. Looking at this last a, it's already accounted for right here, so we don't need to repeat and put a third a in this. All right, so our least common denominator is 5 times a squared times 3, which you could say is 15a squared. And then you have to decide what is missing in each denominator. So in this first denominator, we have 5a squared. The only thing missing here is 3. So we multiply by 3 over 3. In the second denominator, we're missing an a because it's not a squared yet, so we're missing an a. And we're also missing a 5. So we have to multiply the top and bottom by 5a, because then that would make 5a squared multiplied by 3. Then we have 12, so 4 times 3 gives us 12. And then that's being divided by, we can write 15a squared. You can write 5a squared times 3. You could literally just write LCD. Okay, so 12 divided by the LCD minus 7 times 5a gives us 35a over the LCD. And then that is going to be equal to, now we combine them, 12 minus 35a over the least common denominator. All right, at this point, you probably want to change this least common denominator to what it actually is multiplied out. So in this case, 5a squared, or 15a squared, sorry. Then we look at this whole thing. Can anything be reduced here? We can't factor out a number and move it to the front, so we can't do anything there. So yeah, we're actually good here. We can't take this any further. We need to finish with our restriction. A cannot be 0 because you plug 0 in there, it would be divided by 0. All right, and then there is our solution. When you're talking about the restrictions, it's good to make sure you go back and you look at the beginning. Also, 0 is the only restriction from the beginning, so we're still good to go in this case. All right, down to number 3. Number 3 is a little bit different because now we don't have any multiplying in the denominators, it's just adding and subtracting. Well, this adding and subtracting is just the factor. So x minus 2 is one of the factors. X plus 1 is the other factor. So then we can build a least common denominator here, with one of the factors being x minus 2. The other factor is x plus 1. Then we take a look, what's missing out of this denominator? Well, we're missing an x plus 1. So we have to multiply this entire thing by x plus 1 in both the top and the bottom. On the other side, we have to multiply by x minus 2 because that's what's missing in the denominator here. And now, because there's 2 terms we're multiplying by, we have to distribute. So this is 3x plus 3 all over the least common denominator, plus 2x minus 4 over the least common denominator. At this point, now that they're both the least common denominator, we can combine like terms. So we go 3x plus 2x gives us 5x. 3 minus 4 gives us negative 1. And then that's divided by, now I would rewrite x minus 2, x plus 1. Okay. The reason you rewrite this is because you're always looking for if something can cancel here. So like, what is an example of something that could cancel? Say instead of 5x minus 1 here, we got 5x minus 10. Then we could pull a 5 out of the top, so it would be 5x minus 2. And then in the bottom, we would have an x minus 2 and an x plus 1. So then this x minus 2 would cancel with that x minus 2. our final answer would be 5 over x plus 1. That is always a possibility in these, so we always need to make sure nothing cancels after we've added or subtracted. Here we need to talk about the restrictions. Again, what is going to make the denominator 0? X cannot be 2 because you plug 2 right there, it makes it 0. Or it can't be negative 1 because you plug in negative 1 right there, and it would also be 0. So then this would be our final answer. All right, number 4. Number 4 is the first time where we're going to see something where we can actually do some factoring. So let's factor here. We pull the 5 out. That would give us x minus 1. Our least common denominator then, we have 5 one time, so there's a 5. We have an x minus 1, a maximum of 1 time. I know there's an x minus 1 here, but it only shows up 1 time. So then we would say this is 5 multiplied by x minus 1. You go through and you say what's missing. In this first one, we already have 5 times x minus 1, so we don't need to multiply by anything here. In the second one, though, we are missing a 5, so we need to multiply the top and bottom by 5. So this is 6 over our least common denominator plus 5x over our least common denominator. And then we can combine that to 6 plus 5x divided by 5 times x minus 1. Nothing can cancel here yet again, all right? We can't cancel this 5 with this 5 because of this plus sign. Pluses really hinder us when it comes to canceling things out. If it was 6 multiplied by 5x, then we could cancel those 5s. But because it's not, we need to make sure we don't cancel the 5s there, all right? And that is actually for a lot of examples. If you have questions about if things are allowed to cancel, please message me on Canvas. I would love to talk more thoroughly about that. The one x value that we cannot have here is positive 1. All right, and from the top, also positive 1 would make those denominators 0 as well. So positive 1 is just our only restriction. All right, sliding on. Whoops, some answers from earlier today, sorry. Okay, number 5. Number 5 is very similar to the last one in the fact that we can factor from the beginning here. So we pull out a 2, that gives us x plus 3. Now we need to build a least common denominator. So we have a 2 that shows up a maximum of 1 time in a denominator. We have an x plus 3 that shows up a maximum of 1 time in a denominator. And then we also have an x minus 1 that shows up a maximum of 1 time in a denominator. So then we go through, we say what's missing from this denominator, x minus 1. So we multiply the top and bottom by x minus 1. In our other denominator, what's missing is this 2, x plus 3. At this point, I like to factor in that, or FOIL in that 2 to give us 2x plus 6. Notice that's what's right here, right? So 2x plus 6, 2x plus 6. It just makes it a little bit easier than multiplying 5 by 2 and then multiplying that 10 by x plus 3. So I like to keep it as 2x plus 6. And now we can do some distributing. So that's going to be 3x minus 3 over the least common denominator. And then this is 10x plus 30. So plus 10x plus 30 over the least common denominator. And then we can combine like terms. 3x and 10x makes 13x. Negative 3 and 3 makes positive 27. And then I rewrite my least common denominator. So 2, x plus 3, x minus 1. We look to make sure nothing can cancel here. Doesn't look like we have anything that can cancel. So then we write our restrictions. X cannot be negative 3 or positive 1. Double check that those are the same restrictions here. Yep, positive 1. Yep, negative 3. All right. So this then becomes our answer. All right, so that's number 5. Number 6. Factor first. So we have x plus 6, x minus 4. Least common denominator. There's a maximum of 1x in a single denominator. Again, over here there's only one x in this denominator. So in our least common denominator, we have x plus 6. Then we look at x minus 4. That's also needs to be added to our least common denominator. And now we can see what's missing, right? Nothing is missing here. It matches our least common denominator. But we have an x minus 4 that's missing from here, so we multiply the top and the bottom by x minus 4. When you do that, we get x minus 10 over the least common denominator, plus we FOIL this out, so that's x squared. And then we have 3x, negative 4x, so that's negative x. And then 3 and negative 4 makes negative 12 over the least common denominator. And then we can do some adding, right? X plus negative x, those two things are going to cancel. Negative 10 plus negative 12 makes negative 22, and we have an x squared. So x squared minus 22 over x plus 6, x minus 4. X cannot be negative 6 or positive 4 here. And there's our solution. Okay. An example of where a least common denominator in these ones would show up more than a single time would look like this. We would have 1 over, say, x plus 1, plus 1 over x plus 1 multiplied by x plus 1. Then our least common denominator has to have 2 x plus 1s because the maximum number of times there's an x plus 1 is 2. So this denominator would need 2 x plus 1s in it. So we'd have to multiply by 1x plus 1. All right. So that's just a quick example of when you could have a repeat in a denominator. Anyway, let's keep going. So our first step here, factor everything that can factor. Here we have x, and then this is going to be minus 3x minus 1. Here we have 2, x minus 1 gets pulled out of there. And now we can build our least common denominator. X minus 3 shows up once, so we'll have that. X minus 1 shows up once, so we'll also have that. And then there's this 2 that also shows up in there, so we need that. In our first term, the only thing that's missing here is just a 2, so we multiply the top and the bottom by 2. The only thing that's missing in here is this x minus 3, so we multiply the top and the bottom by x minus 3. That's going to give us negative 4x minus 2 over the least common denominator. And then that's plus, this is going to be x squared. This is 2x and negative 3x, so that's negative x again. And then 2 times negative 3 gives us negative 6, and that's also over the least common denominator. And now we can do some simplifying. Negative 4x minus x is negative 5x. I'm going to put that in the middle. We have an x squared in the front, which is right here, and then negative 2 plus negative 6 would give us negative 8. All right, and then that is over x minus 3, x minus 1, and 2. We need to make sure this can't factor. So that's x squared minus 5x minus 8 would be 2 and 4, which would make 6, not 5. And 8 and 1, which makes 7, not 5. So we can't factor that. So then we just write our restrictions. X can't be 3, x can't be 1. And there we go. All righty, number 8. For number 8, factor again. So this is x, x minus 6. On this one we have 2, x minus 6. Build our least common denominator. 1x minus 6, and then there's 1, 2. So this is missing an x over x. This one is missing a 2 over 2. And that is it, that those things are missing, because now this has 2, x minus 6 and x. This has 2, x and x minus 6. So 2 times 3 gives us 6, plus 5x minus x squared. Least common denominator, least common denominator. So that's going to be negative x squared plus 5x plus 6. Let's make sure this thing doesn't factor at all. If we pulled a negative 1 out of here, actually let's write our least common denominator, 2x, x minus 6. If we pull a negative 1 out of here, that gives us x squared minus 5x minus 6. Does that factor? I think it does. X and x, we have negative 6, positive 1. So negative 1 out front here. This is gone. We factored the negative 1 out. This is gone. We just use that to factor again. And it looks like we have an x minus 6 that cancels with an x minus 6. So we have a negative 1 and an x plus 1. And then we have a 2x down here. So this is negative x plus 1 divided by 2x. Throughout this process, though, even though this x minus 6 canceled, still is a restriction. X can't be 6. X can also not be 0. We go back up here and we double check that. In this case, x cannot be 6, right? And in this case, x cannot be 0. So we have our two restrictions. All right, on to number 9. Factor what we can. This is going to be x minus 6, x minus 6. So our least common denominator here, this time, this x, the maximum number of times it shows up is 2. So x minus 6, x minus 6, and then there's 1 x plus 2 sitting out here. So then what this is missing is it's missing x minus 6 multiplied by x plus 2. X minus 6 multiplied by x plus 2. The middle section is missing an x plus 2, so an x plus 2 here and an x plus 2 here. And then the last one is missing literally this whole thing. So x squared minus 12x plus 36 over x squared minus 12x plus 36, which is just known as x minus 6 times x minus 6. Okay? This is where it starts to get tedious because there is just a ton of multiplication that has to go into this question, right? So let's FOIL this together first. So this is going to become x squared, negative 6 and positive 2 makes negative 4x, negative 6 and positive 2 multiplied makes negative 12. So then our first term is going to be 4x squared minus 16x minus 48. That's all over the LCD. Let's go to our next term. So this is going to be a 5x squared. So plus 5x squared. This is 10x. This is negative 2x. So that's positive 8x. And then negative 2 times positive 2 gives us negative 4 over the least common denominator. And then finally out here we have 2x squared minus 24x plus 72, also over the least common denominator. So tons of multiplying that just happened right there. Now we just combine all the like terms. We have 4x squared here, 5x squared here, 2x squared there, so 4 plus 5 plus 2 gives us 11x squared. Then we have negative 16x, positive 8x, negative 24x. So negative 16 and positive 8 makes negative 8. Negative 8 and negative 24 makes negative 32x. And then negative 48 plus negative 4 plus positive 72. What does that make? Negative 48 and negative 4 makes negative 44. And then 72 minus 44, so we subtract 4, which would give us 68. 68 minus 40 is just 20, right? So that's just positive 20. Wait, that doesn't make sense. Positive, we did 72, positive 28. There it is. Yeah, definitely. positive 28, and then that is all divided by our least common denominator, which I'll rewrite x minus 6, x minus 6, x plus 2. Okay, so tons and tons of multiplying going into that. Let's look here. I have no idea if this factors. Our only option is 11x and x. Can we do that with 28 to make 32? If we did 28 divided by 4 would be 44. So if we went negative 4 here, that would be negative 44. And then if we went positive 7, negative 44 and positive 7 doesn't quite make 32. I think that's as close as we're going to get to it. All right. So I think this is good here. I think we're good. X can just not be 6 and negative 2. And there we go. All right, on to the double fraction ones here. These ones are a little bit different because you have to find a least common denominator in the top. So I'm going to put LCD of the top versus an LCD of the bottom. Our LCD of the top here, we have 6 and 3. The least common multiple of those two things is 6. So 6 is our LCD. So we just need to multiply this by 2 over 2. In the bottom, we have 5 and 10. Least common multiple is 10. So we just need to multiply this one by 2 over 2. So what does that give us? X over 6 minus 2x over 6 divided by. And then we have 2x over 10 minus 7 over 10. So then now we can combine these things. So x minus 2x gives us negative x over 6. And then this is going to be divided by 2x minus 7 all over 10. Now that everything is combined, there's no pluses and minuses in of fractions being combined. This comes back to our division problems. So this is negative x over 6 multiplied by 10 over 2x minus 7. Then we can reduce 10 and 6. Both 2 comes out of that, so 3 and 2. So then we get negative 2x over 3 multiplied by 2x minus 7. By all means, you could put that 3 into there, but you don't have to. All right, and then let's think about all of our restrictions here. In this case, we go back to this. We can't divide by 0 because there's just numbers in the denominator from the beginning. But at the end, we could end up dividing by 0 if x was equal to 7/2. So we can't have 7/2 there, right? And if you're struggling where that comes from, 2x minus 7 equals 0. So that's 2x equals 7. So x is equal to 7/2, right? That's what x can't be. So then there's our solution. All right, only 2 questions to go. We got this. Same thing as the last one. We need to go least common denominator of the top and a least common denominator of the bottom. If we're looking at the top, we have an x and an x minus 5. So this gets multiplied by x over x. This one will get multiplied by x minus 5 over x minus 5. So 2x and x gives us 2x squared. That's going to be 3x minus 15. So that's plus 3x minus 15. All of that is our least common denominator of the top. And then that's divided by, least common denominator of the bottom is just x minus 5. This one we'd have to go x minus 5 over x minus 5. This is technically 1 divided by 1. So when we're writing this, it literally becomes x minus 5 over x minus 5. Or actually, let's combine it right away. Right? So this is x minus 5 when you distribute this 1. And then minus 4 over our LCD of the bottom. Do some simplifying here. So we have 2x squared. Nothing changes in the top. 2x squared plus 3x minus 15 over LCD top divided by x minus 9 LCD bot. Now we can rewrite this as 2x squared plus 3x minus 15 over my LCD of the top was x times x minus 5 multiplied by LCD of the bottom was just x minus 5, and that's going to be x minus 9 here. It would be a good idea to look to see if this can factor. So we go 2x and x to make sure nothing else can cancel here. We need positive in the middle. So if we went positive 3, that would make 6 minus 5. That doesn't work. So 3 and 5 is not looking like it's going to work, because if we went positive 5 here, that's positive 10. And then minus 3 there, that would still just be 7. So also doesn't work. So this is not going to factor there. But we have x minus 5 and x minus 5 that cancel. So that leaves us with 2x squared plus 3x minus 15 over x times x minus 9. Our restrictions here, x could not be 5. Even though it disappeared, it still couldn't be 5. There was a 9 in there, and there was also a 0. 0 here, 9 here. You'll notice that 5 is also in the beginning, so if you lose it at the end, you can look back to your beginning and be like, oh yeah, we can't divide by when x is equal to 5, because that would be dividing by 0. All right, and then here's our solution. Alrighty, last question. Least common denominator of top. We have, this is technically 2, x minus 2. So then we have 1, 2 is the maximum number of 2's, and then there's also, what is going on? There's also an x minus 2 that goes there. So this is x minus 2 over x minus 2. This has everything here. So then let's rewrite that top section as in x minus 2, and this is going to be minus 5, all divided by LCD of the top. And then our LCD, oh, there is only one thing in the bottom, so that's literally just all divided by x over, we could pull out a 2, which would make this x squared minus 3x plus 2. Does that factor further? It does. So 2x and x minus 2 minus 1. And so I'm actually just going to slide that right into here. Okay. And now we can do some rewriting. This is x minus 3 over 2 times x minus 2 multiplied by, we have a 2, x minus 2, x minus 1 divided by just x. 2, 2, x minus 2, x minus 2. So we're left with x minus 3 times x minus 1 divided by just x. X in this case cannot be 0 because of this. It also couldn't be 2 because even though it canceled originally, right, we couldn't plug 2 into this or we would be dividing by 0. So we couldn't be 0 or 2. And that's going to be it. And then there is our final answer. All right. So hopefully this helped. I know I went kind of fast. I knew this video was going to be long. But as always, if you have questions, please message me on Canvas or just ask me in class. I love to answer questions in person. It's a little bit easier to explain things. Anyway, I hope you have a great day, and see you soon.